Yeah. So day six we continue on the okay, that's a mistake that is there. Okay, it should not be called the infra architect. That's a mistake on my presentation. It's called the DB architect. That's database architect. Okay, on day 6. So all you folks who are primarily on maybe more oriented towards database. Okay, so here and possibly people who like in terms of, you can say, architecture design patterns. Here there's this day is primarily dedicated to all those kind of complexities. This day, like is where the challenges of Microsoft infrastructure we discuss in terms of implementation and in terms of design patterns. Okay, the greatest problem. See, okay, let me ask you a question. In whatever you implemented, I mean, what are systems you have worked on as tester or DevOps or manager or developers? What is the greatest challenge that you think the systems faced? What component? I would want to hear from you guys.
What component in the sense, Sumith?
Okay, what concern? Okay, there are various concerns of your system, right? There are 3-layer architecture. There are you know, whatever, like you think like in the entire system that you build, right? What is the specific layer or what is the specific concern? What is the specific context where usually the systems fail, because of which the systems fail? What is that one primary reason?
So I faced like moving private sector migration. So it's a big thing. Like when coming to the complete architecture was delayed in public thing, so that we moved to the private. It's a great thing to move like this. I feel more difficult on that. Like because of without downtime and all, we need to move that.
Okay, yeah. So okay, yeah. What else? That's a good point. What else? Anybody else?
Sumith, in production, we have seen issues with the firewalls and sometimes with the connectivity.
Right. Yep. That's also one point. Yeah. Something where everything comes to an end. I mean, usually
when the DB server is down, probably our system will not be up, like especially with respect to Sterling OMS.
Great. That is one which great it came from you, Shweta. So that's one point. I think as years and years when things go on, when you've seen systems, you would see, yeah, there are issues with security, there are issues with messaging, there are issues possibly with process, there are issues with possibly, you can say, yeah, optimization, code entropy, whatever, like weak code, bad coding principles, whatever. Those kind of things are there. But one place where everything comes to a halt is database. When it's not available, we have seen it almost every time across systems. So Microservices is one important, you can say, not a solution, but a way of thinking where we try to mitigate those problems. Okay, that is one very important thing. We'll discuss that as time goes ahead. So with microservices, we try to handle that thing which is database. So usually we can say it's like the albatross around the architect's neck. So that phrase means that it is the one which causes the most important nagging problems in systems, because of which systems have downtimes, they have performance problems, scalability problems, they have stability problems, and a very dissatisfied customer, dissatisfied users. So yeah, like you must have seen when we have this Flipkart big billion days. You guys are in the retail kind of industry, right? So Flipkart big billion days, the business which goes on a very like a booming business they have. That time, many times it just fails. It totally comes to a halt. It's primarily because database is not able to. The systems fail to scale. Okay, but obviously the entire load is on database. Whatever way they used it, whether it's distributed, whether it's like whether it's clustered format, whether it is a real application clustering, whatever they use, it comes to a halt. So how those kind of situations, okay, especially in public facing internet sites, how we can mitigate them. Microservices helps in that. Okay, so here we talk about on day 6 we'll talk about database per service, shared database, Saga, API composition, and CQRS. Okay, command query responsibility segregation, domain event sourcing, CAP theorem. Okay, so CAP theorem and two-phase commit. Okay, so anybody of you knows what is two-phase commit? Like at a very basic level, what's two-phase commit? Any of you developer side who knows what is two-phase commit? Just checking. Okay. Two-phase commit usually means like a distributed transaction. Okay. So distributed transaction means usually what happens, we have one node most of the times who has to do one transaction, okay, a single transaction. And that is let's say an order that is booked by the customer has to be written to the database. Now, when this is happening, it's mostly going to happen on one node. But with microservices or with other kind of architectures, things might happen across nodes. We have to check with other nodes, okay, because data has to be committed across two nodes or two or n nodes. So what we do at the first phase, we go and check if every participating node is ready to commit the data. And second phase, we'll go ahead and commit it. So that's why it's called the two-phase commit protocol. So that is into the area of distributed transactions. What we'll talk on day 6 will be primarily in the area, the issues will be in the area of, or design patterns will be in the area of distributed transactions. Okay. Okay. So now by day 6, we would have mostly done with most of the infrastructure concerns, development, database, some amount of messaging, and day 7, we'll move to the DevOps part of it. Okay. Now this day, I'm yet to discuss because I'm from the development side. I have concepts of Docker. I will try and take you through Docker on Windows, but Docker, Kubernetes, AWS world is all on the DevOps side. The CI/CD, Maven, Git, Jenkins, GCP or Azure, whatever. If you are to use AWS for this, I'll be taking you through concepts of it. We might have an SME, a subject matter expert on this, who's a DevOps, like you can say senior DevOps professional or a DevOps trainer. He might join. Okay, anyway, Monica will inform to Shweta what is the plan. So that is going to be decided that time, like what we're going to do. If SME, the subject matter expert, is not available, then I'll take you through concepts of it and try to demonstrate. Obviously, Maven is easy to demonstrate. I'll take you through a concept of everything, and Docker I'll try to demonstrate on Windows. So that is the idea of day 7. Okay. Now moving ahead, day 8. Once we are done with all of these, we have to now think of the, you can say, cross-cutting concerns or the ops concerns. So ops concerns, not like the developer operations, in terms of the application operations, like in terms of how we are going to do the security and authentication, how we're going to do logging, log aggregation, health monitoring, okay, debugging, tracing, and audit logging. So, when we are having, let's say, microservices, how, while talking to the external world, how we're going to do that security and authentication? How are we going to make sure that the whatever, like the token or the security mechanism we are using can be used for inter-service communication? How to log? How will you do the logging? Okay, so you think of logging. Some time ago, I just mentioned in terms of L2, L3 support that we would have to look at the logs when we are going to do some debugging. Okay, that is one important thing for support. Now, when we come to microservices, how we'll make sure that when we are tracing a request, okay, so there are various tools available for that. If people don't use the tools, there should be a way to build it into the system to make sure that the logging allows us to debug applications. There's log aggregation. Log aggregation happens, and there's a way to, I don't know, whatever system, like maybe you use ELK or whatever to log aggregation mechanism you use, your way to see what is how to analyze the logs. Okay. And then another important thing, okay, when think of now microservices, as microservice grows, okay, you might have let's say a company might have 50 microservices or even 500 microservices. So it's going to become a very big mess. How are we going to make sure that we are able to maintain them in terms of monitoring them? So there is something called as observability. How we're going to build observability into it and how we're going to monitor them. Okay, so those kind of things are ones which we'll take across on day 8. Okay, with this, most of the things that I can say technically, okay, you will be equipped in terms of the entire journey of thought process to implementation, to DevOps, to ops infrastructure. You'll have some code with you. Each one of you will have some code to refer on the GitHub. Possibly you have the book, which is pre and post reference. You'll have some, I'll share a few articles during this time. You have some articles for reference. So you'll build that body of knowledge for yourself. And obviously this course, which is there, where you'll be participating daily. and you can anytime push questions. I think by yourself as well, but otherwise maybe through Shweta, directly to me, and then the following day I can answer them. Some of them I may also not have answered to, okay, because I've done session previously. People came out with great thoughts, okay, and some because everybody has got experience. They've worked on something or the other. Even if it's not about Microservice concepts, it might be about some specific process. Like let's say, what are the kind of standards testing frameworks available? That's some of the questions which came up. Then yeah, so like that. So if you have any such questions, you come up with it so that you either ask it during the session or you send to Shweta, and then we can discuss it across for everybody's benefit. We can discuss those points. So day 9. So day 9, why I'm calling engineering manager? Because the idea of agile planning for testing, and this final, you can say source code management, all these ideally, you can say the control in a team would be managed by engineering manager. Okay, each one of you will be part of it. Right from, beginning, you might have been doing some amount of estimation, you might be doing some amount of milestone tracking, you definitely would have done some amount of testing, they would have done branch their code many times, and some amount of system administration or DevOps, each one of you have participated. Yeah, I think in SACS, what was told to me is that everybody does the DevOps as well. It's not like DevOps is not a very focused activity. So that, it's not a very demarcated activity. Everybody is involved in the DevOps activity. So on this day, what are the kind of thing in terms of manager who has to plan this move? What are the kind of you can say milestones that he has to plan for? Typical. It has to be tailored to your organization. And what are the kind of testing that he'll plan for? So what is a branching strategy? So if a team, if an organization decides that I want to move to microservice, like I said, the typical way would be to spend some time on research. Every organization, okay, they gain the skills, they gain the abilities, and some amount of time to build their reference implementation. It's very important. So that word, reference implementation, what I am very much a great proponent of that. Some organizations do not do that. They just move ahead with the development, saying that it's okay, it's fine. But I'm not I'm not encourage that. I say that if an organization has to move to a new technology, new architecture, new thought process, better that they build a like just a POC prototype, because it's architectural, you build a reference implementation. So that reference implementation, what is going to happen while people are continuing to work on the product, okay, where they might have support issues, some other issues, possibly enhancements. There is few folks, possibly a senior architect or a lead engineer along with the manager, whatever the company decides, whose focused work will be to build the reference implementation. Like it'll be something that which you people bring in, or you might have discussion checkpoints and research phase, where you bring in all the things an organization wants to do in terms of infrastructure, in terms of the kind of sample microservices. Let's say organization wants to additionally include on the cloud side, like you might have DevOps also along with that. Okay, in your organization, everybody does everything. So let's say he's on the DevOps side as well, and he wants to additionally prototype the S3 service, Amazon S3 service, or the RDS. So all those things, when it's built into the reference implementation, there you have built a quality reference prototype, which you can vouch for, saying that I spent 1 month, I spent 2 months, I spent 3 months of one person's effort, and I have a quality reference implementation. Now, this effort can be used across the organization. Sorry, there's somebody who has a question. Nitin, can you go?